centuries, humanity has gazed up at the night sky and wondered, are we alone? And no celestial body has captured our imagination quite like the red planet, Mars. It's our cosmic neighbor. A world of rusty dust and giant volcanoes, but could it also be a cradle of life? Welcome back to our channel, where today we're diving deep into one of the biggest questions ever asked. Is there life on Mars? Let's travel back in time, not just a few years, but billions of years. Today, Mars is a cold, dry desert with a wispy thin atmosphere, but the evidence tells us it wasn't always this way. We've seen ancient riverbeds carved into the landscape, dried up deltas, and minerals that could only have formed in the presence of water. Rovers like Curiosity and Perseverance have found definitive proof that Mars once hosted vast lakes and possibly even oceans for millions of years. And where there's water, there's the potential for life. This ancient, watery Mars was a very different world, a warmer, wetter planet that might have had all the right ingredients for life to emerge, just as it did here on Earth. So, what are these ingredients for life? Scientists often talk about the Goldilocks zone for a planet, but there's also a chemical recipe. You need a few key elements: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. We call them CHNOPs for short. You also need a source of energy, like sunlight or chemical reactions, and liquid water to act as a solvent, mixing everything together. The exciting part? We found all these ingredients on Mars. Rovers have detected complex organic molecules, the very building blocks of life, preserved in ancient Martian rocks. This isn't proof of life itself, but it's like finding a complete pantry in an abandoned house. All the ingredients were there. The big question is, did anything ever start cooking? If life did exist, where would we find it? It's unlikely we'll stumble upon a Martian strolling across the dunes. If there's life on Mars, it's probably microbial, tiny, single-celled organisms. And they wouldn't be on the surface. The surface of Mars today is brutal. It's blasted by intense solar radiation and as wild temperature swings. Any life would have had to retreat underground. Think of it like this: life on Mars would be an extremophile, an organism that thrives in conditions we would consider deadly here on Earth. We find life in the most shocking places, in boiling volcanic vents at the bottom of the ocean, deep within Antarctic ice, and in highly acidic pools. Life is tenacious. So, the search on Mars is now focused on drilling beneath the surface, looking for sheltered pockets where liquid water might still exist. Perhaps in salty brines that stay liquid at freezing temperatures. These subterranean oases could be the last refuge for Martian life. Another fascinating clue comes from a gas, methane. On Earth, the vast majority of methane in our atmosphere is produced by living organisms, from microbes in a cow's stomach to bacteria in wetlands. And guess what? We've detected methane on Mars. It's mysterious. It appears in plumes, then disappears. Its source is a huge puzzle. It could be produced by geological processes, like reactions between rock and water. But it could also be a sign of active biology, a birth from microbes living deep underground. Scientists are desperately trying to pinpoint the source of these methane plumes. If we could trace one back to its origin and find its biological, it would be one of the most profound discoveries in human history. Our robotic explorers are the heroes of this story. Rovers like Perseverance are equipped with incredible instruments designed to hunt for these signs of ancient life, what we call biosignatures. Percy is currently drilling into the Jezero crater, an ancient river delta that's a prime spot to find preserved organic matter. It's not just looking, it's collecting. The Mars Sample Return mission is an audacious plan to bring these rock samples back to Earth. Imagine, in the next decade or so, scientists in labs right here on our planet could be analyzing actual Martian soil, using a full suite of equipment far more powerful than anything we can send on a rover. This will be our best shot at finding definitive, undeniable proof of past life. So, let's bring it all together. What's the verdict? Is there life on Mars? The honest answer is, we don't know yet. But the evidence is tantalizing and points in an exciting direction. We know Mars had the right conditions in its past. We know it had all the necessary chemical ingredients. We have mysterious clues like methane that could hint at life today, and we are on the cusp of bringing pieces of Mars back home to study. The search for life on Mars isn't just about finding little green men. It's about understanding our own place in the universe. If we find that life started independently onto adjacent planets, it would suggest that life isn't a rare miracle, but a common cosmic phenomenon. It would mean the universe is likely teeming with it. The next few years are going to be absolutely thrilling for planetary science. Each new discovery, each rock sample, brings us one step closer to answering that age-old question. Whether Mars is a sterile world or a home to past or a prison life, the answer will change everything. What do you think? Do you believe we'll find evidence of life on Mars in our lifetime? Let me know your thoughts in the comments below. Thanks for joining me on this cosmic journey today. If you enjoyed this video, don't forget to hit the like button, subscribe, and ring the bell so you never miss an update on our search for answers in the universe. Until next time, keep looking up.